5 years ago, if you wanted to add a major feature to a software project, you need an engineer. Someone who could read 1,000 lines of code, understand the architecture, find the right files, make changes, run tests, fix errors. But today, a developer can open Cursor and simply type, add Google authentication to my application. And an AI agent can explore the codebase, modify multiple files, create new components, run commands, and help complete the task. But the interesting question is not what can Cursor do. The interesting question is what architecture allows an AI system to behave like a software engineer. Because Cursor is not just a chatbot inside an editor. Behind that simple interface is a collection of systems working together. A code intelligence system, a context engine, an AI agent, a tool execution layer, a model orchestration platform, and a code modification pipeline. Today, we are going to design the architecture behind an AI coding agent. Let's start with the simplest possible design. A developer writes a prompt, the system sends it to an LLM, the LLM returns code, something like this. This works for small questions. For example, write a Python function to sort a list. But software engineering is different. A real application is not one function. It is thousands of interconnected files. The AI needs to understand where authentication lives, how APIs are connected, what data schema exists, which components depend on each other. A model setting alone cannot do this. So the architecture needs something more. A production AI coding agent needs multiple systems. At the highest level, the key idea is the LLM is not the product. The LLM is one component inside a larger software system. The surrounding architecture is what turns a language model into an engineer. The first layer is the application developers interact with, the cursor editor. This layer is responsible for understanding the developer's action, showing AI responses, displaying code changes, managing conversation, tracking the current workspace. But it also provides something extremely important, context. For example, which file is open, where is the cursor, what code is selected, what error exists, what changes happened recently. The IDE is not just a chat window, it is the AI connection to a developer environment. Now we reach the first major engineering challenge. How does an AI understand a massive code base? Imagine a large company repository. You cannot send this entire repository to an AI model. So before the AI answers anything, the system builds an understanding of the code base, the architecture. The system analyzes files, functions, classes, imports, dependencies, relationships. It creates a map of the software. This is similar to how Google works. Google does not search the entire internet every time you search. It creates an index first. An AI coding agent needs the same thing. It needs a search engine for your code. Now the system understands the repository, but there is another problem. What information should the AI actually see? Suppose you ask add authentication. Your project may have login components, user models, database tables, API routes, middleware, tests. Which file matter? This is the job of the context engine. Think of it as the AI information filter. The context engine combines current file, open tabs, repository search, code relationships, previous conversation, error messages. The goal is simple. Give the model enough information to solve the problem, but not so much that it becomes slow and expensive. This balance is one of the hardest problems in AI engineering. Now we reach the core of the system, the agent. A normal chatbot follows this pattern, but software engineering requires a process. For example, add Google authentication. The agent needs to find existing authentication logic, understand the architecture, create a plan, modify files, run tests, fix problems. This requires an orchestration layer. The agent is constantly asking, what should I do next? This is called the agent loop. Think, act, observe, repeat. The AI model itself cannot change your computer. It cannot open files, it cannot run commands, it cannot execute tests. So the agent needs tools. The model decides what action should happen, the tool performs the action. The results come back, then the model decides the next step. This separation is what makes AI agent powerful. The model provides reasoning, the tools provide abilities. The final piece is the model layer. An AI coding company cannot permanently depend on one model. Today, best model might be Claude. Tomorrow, it might be GPT or Gemini. So companies create a model abstraction layer. The layer handles routing, cost optimization, latency, model selection, reliability. The AI model becomes irreplicable. The architecture remains. Generating code is only half the challenge. The system also needs to safely apply changes. The pipeline. Instead of blindly rewriting your project, the system creates a patch, show exactly what changed, then applies it. This is critical because software change needs trust. So if we put everything together, this is the architecture behind an AI software engineer. The important lesson is the future of AI application will not be built by simply connecting a chatbot to an interface. The winning system will combine models, retrieval, planning, tools, memory, execution, and feedback loops. Cursor is not powerful because it has access to an LLM. It is powerful because it built an entire engineering system around that LLM. And the architecture is not unique to Cursor. Cloud Code, GitHub Copilot Agent, Windsurf, OpenAI Codex, all of these systems are moving towards the same idea. AI is no longer just answering questions. It is becoming an active participant in the software development process. In the next video, we'll break down another AI engineering system and see how different companies are solving the same problem with different architectures. Thank you for watching this video. See you in the next one. Peace.